In this video, we are going to determine the domain of a function and whether it has holes or asymptotes. So what is the domain of the rational function x squared plus 3x plus 2 all over x squared plus 5x plus 4? And what can we say about each gap in the domain? Is it a hole or an asymptote? So first, let's determine what the domain of this function is. So we have x squared plus 3x plus 2 all over x squared plus 5x plus 4. So to determine the domain, we want to find where the denominator equals 0, so we can make sure we take that out of the domain. Since we have two functions, one function over another function, it would be good to see if we can factor each one and see if we get any cancellation. So let's look at x squared plus 3x plus 2. We want to find two numbers that multiply to 2 and add to 3. So we have 2 times 1, which is 2, and 2 plus 1 is 3. So the numerator factors as x plus 2 times x plus 1. Now let's take a look at the denominator. We have x squared plus 5x plus 4. So we want two numbers that multiply to 4 and add to 5. So if we do 4 times 1, that's 4, and 4 plus 1 is 5. There we go. So we have x plus 4 times x plus 1. Now since we have x plus 1 in the numerator and denominator, this really equals x plus 2 over x plus 4. But we need x to not be minus 1, and x cannot be minus 4, because if it is, then this equals 0. So to make this more clear, we want that x plus 4 times x plus 1 equals not 0, because that's in the denominator of the fraction. So that is where these conditions come from. Now, how do we write the domain in interval notation? Well, basically we can have any number in the domain except for minus 1 and minus 4. So we can go from minus infinity up to minus 4, which is not included. So we have curved parenthesis. And we take the union from minus 4, which again we're using the curved parentheses because minus 4 is not included, up to minus 1, which is also not included. And then we go from minus 1 to infinity. So this is our domain. Now, we want to know if there's a hole or an asymptote at the gaps. So what happens at each gap? Well, since the x plus 1 basically canceled from the numerator and denominator, what that tells us is that at x equals minus 1, there is a hole. Now, we're left with x plus 2 over x plus 4. So what that tells us is that at x equals minus 4, there's going to be what we call a blow up, and so there's going to be an asymptote at x equals minus 4. And this is our final answer. If this video was helpful, feel free to like and subscribe.